Okay, for our second word problem, we're actually going to build off the first word problem. So I'm going to keep some of the information from word problem 1, basically n, y, and the linear relationship we found between them. And we're going to go ahead and move on to the next problem. The farmer wants to maximize the total yield in ounces of beans produced per square yard, B, as a function of the number of stalks planted. Part A. Find the total yield in ounces of beans per square yard, B, as a function of the number of beanstalks planted per square yard, N. Question part B. What number of beanstalks planted per square yard maximizes the yield of beans planted per square yard? All right, so now that we've written it down, let's go ahead and let's translate this as best we can. So if we look at this, we see the word maximize. That's a mathematical word which means find the largest value, basically. And what we want to maximize is the total yield in ounces of beans produced per square yard. Now, if you notice, it's given us a new variable, B, and that's equal to the total yield of beans in ounces per square yard. Okay, so what we should envision this farmer doing is he's not just trying to figure out what's the best way to get the number of beans per stalk. He wants to figure out what's the best number of stalks to plant in the ground to get the most beans. Because if it takes 2 stalks, that's fine. If it takes 20 stalks, that's fine. It takes 40 stalks, that's fine. What he ultimately wants is the most amount of beans. So this is figuring out how many beans he can get if he plants at a certain rate, N. Okay, now if we look at this, the goal is to maximize this. So let's go ahead and let's just say maximize B, and we'll keep that in the back of our head as something that we need to be shooting for at some point down the road. Okay, now for part A, it wants us to find the total yield in ounces of beans per square yard, B, as a function of the number of beanstalks planted per square yard, N. So what it wants us to find is an expression for B of N, where N is the number of stalks that we've planted per square yard, and B is the total yield of beans in ounces we got from planting that many stalks in there. Now, this is one of the stages where we have to sort of reason mathematically and figure out what's going on. So let's just go ahead and think about this for a minute. If I plant 10 bean stalks and I get 20 ounces of beans per stalk, then that means that I get 20 ounces per stalk times 10 stalks, that's 200 stalks. So if you're having trouble figuring out something like this, just try a couple of numbers. So let's write that down. So if I got 20 ounces of beans per stalk, and then I had 10 stalks per square yard, if I wanted to figure out the total number of beans, well, I get 20 ounces per each, so then this is just going to be multiplied, okay? So that's the thing that I need to do. I need to take the number of, the amount of beans or yield of beans I get per stalk and multiply that by the number of stalks per square yard. And if I look at that, that's basically going to be y times n, okay? So now we found the relation, but this wants us to find it as a function of the number of stalks planted per square yard, which means that we want the yield to only depend on that, which means that this y, we need to get rid of it. And we can't just simply erase it. The y actually has a very important meaning. It's the number of beans you get per stalk. But we already have figured out a relation for that. That's right over here. So what we can do is we can take this expression for y and substitute this expression in. And if we do that, we get negative 1/2 n plus 46 times n. And if we look at this, this is going to be equal to, let's just multiply it out, negative 1/2 n squared plus 46n. And so this gives us the maximum number of, this gives us the amount of beans we're going to get per square yard if we plant a certain number. So this gives us our B of n. So then what we've done is we've basically sort of gotten rid of this intermediate variable that is the yield per stalk, and basically figured out that for any number of stalks that we plant in a square yard, we're going to get a certain amount of beans from that number of stalks, and this incorporates both the number of stalks that we planted and the yield per stalk. Okay, So now that we've found part A, that is, we found the total yield of beans per square yard as a function of the number of stalks we plant per square yard, we need to go ahead and maximize this. We need to find the maximum value. Now, if this were some other function, that might not be true, but if we look at this carefully, this is essentially a quadratic. What that means is that if we look at it, it's a variable squared times some number plus that variable times a number, and then sometimes there's another number, but here it's just gone at 0. So if we look at this, this is a quadratic. And if we notice, the coefficient of the squared term, or the squared variable, is negative. So this is actually a downward facing quadratic, which means that the maximum is going to be right up here. It happens at the vertex. So we'll just find the vertex, and that'll tell us all the information we need to know, where if we were to graph this, our input is n, so we write that down as our horizontal, and b is our output, so that's going to be our vertical value. So if we want to find the vertex of this, if you recall, the formula that you probably have memorized is negative b over 2a. Now, first of all, the b is confusing, but at least it's capital, so we're not in too much trouble. And notice that this is the horizontal coordinate, so we're going to let that equal n. So when we say b, what we really mean is the coefficient of the variable that's just by itself. It has no powers on it. So if we look at this, this should be negative 46, and then over 2 times a, and in this case, the coefficient of our, the a is the coefficient of n squared, which is negative 1/2. So then if we go ahead and calculate this out, 2 times negative 1/2 is negative 1 over negative 46, 46. So that tells us that the x-coordinate, or the n-coordinate in this case, is 46. Now to find a vertical coordinate, we just plug this into that. So we get b of n, we get b of 46, because if we plug in 46 here, that'll give us the vertical coordinate. And so we just plug this in, so we get negative 1/2 46 squared plus, well, that's actually 46 times 46 again. And so if we calculate that all out, we get 1058. So then if we look at this, this is the number of stalks per, so this is the vertical coordinate here, And then if we look at what this means, this is telling us that if we want to maximize the number of beans that the farmer gets per square yard, we should plant 46 stalks per square yard. So to write that down, so to maximize output, the farmer should plant 46 stalks per square yard to yield 1,058 ounces per square yard. So just from a few bits of basically agricultural data, we can actually give this farmer good advice to maximize his yield in beans. All we needed to do was to first find the linear relationship between how densely we plant the stalks to the yield per stalk. And then to find the actual yield, we just multiply these two variables to find this function as a function of the number of stalks planted. And then we just have a math problem. We need to take this function and maximize it, which means we just find the tallest point on the graph. And since this is a downward facing quadratic, that's just the vertex. And then we just need to use what we know about quadratic functions. That is, find the horizontal coordinate of the vertex, plug that into the function to find the vertical coordinate, and we've done all the math that we need to do. We have the answer that we want to give the farmer, and the farmer doesn't really want to worry too much about the rest of this. What we can tell them is, if you want to maximize your output, get the most beans per square yard, you should plant 46 stalks per square yard, and you should expect about 1,058 ounces of beans per square yard.